Well, why don't we get started with some intros, and then as people come in, they can get caught up. So I will start with myself. I'm Olivia Cooper, she, her pronouns. I am a PhD candidate at UT Austin, studying astronomy, and I'm also an Astrobites writer. I am the co-chair of the Climate Change Committee within Astrobites, and we are focusing on this intersection between climate change and astronomy, and using our platform of science communication to really look into this. I would like to welcome our speakers today, James, Ryan, and Dan. We have a few climate communicators here today talking about specifically climate change in education spaces. So from two different perspectives, from the perspective of the classroom and then also planetarium spaces. And this is the first Zoom event of Earth Week 2023. This is our second year of Earth Week from Astrobites. And I'm excited to hear from our speakers today and for the whole week of programming. So thank you all for joining. And I wanted to start with some intros, just background on who our speakers are and have them introduce themselves. So why don't we start with James?
Very good. Thank you so much, Olivia. Hello, everybody. Thank you for joining today. I am a professor of astronomy at Smith College, which is Olivia's alma mater. And we're a small liberal arts college, traditionally for women, in Western Massachusetts. And I have been involved in climate stuff for a long time, since I was a grad student myself back in the 80s and 90s, and have had lots of opportunity to see attitudes towards climate change over the years, and have, as an environmental activist in general, had many opportunities to engage in various ways. And that certainly translates into education spaces in obvious ways. And I'm delighted to be able to talk about it more and hear what my colleagues and the rest of the attendees today have to say about this as well. Students at Smith come to college with a lot of climate experience already in many cases, and it's definitely a challenge and an evolving one to figure out how best to engage with them and with the society at large. As we all know, it's not just a simple case of providing the scientific information. And I'll have more to say about that, and I look forward to hearing everybody else's thoughts too.
Great, thanks, James. Yeah, go ahead, Ryan.
Okay, my name is Ryan Wyatt. I'm the Senior Director of Morrison Planetarium and Science Visualization at the California Academy of Sciences in San Francisco. So I started out in grad school in astronomy, but as I said in my bio for Astrobites, I blame Hubble, because working with first generation Hubble Space Telescope data, trying to do photometry with it, for some reason I ended up leaving the astronomy research field and have been doing education work for 30 some odd years now, mostly focused on the planetarium space. And making that transition to the planetarium world was exciting for me, because it allowed me this opportunity to take a kind of data-driven approach to the way we visualize content in a planetarium. I'll talk a little bit more about sort of contemporary digital planetariums, but it's an exciting venue, not just for teaching sort of contemporary modern astronomy, but also, as I like to say, putting the planet back in planetariums. So bringing some of these stories into a space where a lot of people are engaged with content, have their minds sort of open to new ideas, and to be able to integrate that and weave these stories of climate and environment into stories about astronomy and our planet is an exciting opportunity. My sort of silent partner in this, because I'm coming to you from a rather barren conference room just outside Washington, D.C., where I've had some meetings. But my partner, who is in San Francisco, is Dan Tell, who is the manager of our engineering team. He's going to be running my visuals for me so that I can highlight some exciting stuff.
Great, thank you both. And I'd love to invite James to get started with his portion of the session.
Very good. Here goes. Is that showing okay?
Yes.
All right. Here's the traditional approach. I don't use this anymore, but for quite a few years I did. In Intro Astro, Astronomy 100 at Smith, or Astronomy 111 at Smith, I would do this stuff, and this is fine. Anybody who wants these slides, I'm happy to provide them. I think there is a space for this traditional approach where you supply the information about climate change. You do the best you can to give a compelling lecture. You bring the best graphics and movies and analogies you possibly can. These are all good rules. I love the rule to keep it local. Try to think about your audience and what matters to them on their most local basis, and hone a climate message to that locality. And I think there's no force stronger known in the universe than peer pressure. And that means setting the norm so that people will make decisions on personal basis or even political basis based on what they perceive as the norm. So part of our job is to set the norm. And that means make it look as if regular folks care about climate change. Okay, great. So I do all this. Here's how it might look. I'm going to zip through very, very quickly slides that I used to show regularly in my intro astro classes. And I still do, but you know what? I really just give them the PDF and I run through it in class now. I don't dwell on these slides anymore the way I used to. I talk about how the atmosphere is both a sunscreen and a blanket, how it protects us from UV through the ozone layer, how ozone is created and destroyed. And I talk about the greenhouse effect, and so most of these students already know something about radiation. I'll assume this audience today does too. And we talk about greenhouse gases, and we use applets to demonstrate absorption of infrared radiation. And then I ask them a quick quiz. You know, it's good lecture practice to break up the lecture and have a quick back and forth with your audience. So I ask them this question: well, where does the infrared radiation come from? Is it the sun or the Earth's surface or the Earth's atmosphere? So lots of room for confusion, and you know, maybe we can clear it up with a discussion. Maybe we can't. I always talk about the different planets. I'm sure you other astronomers do in your classes, and the different temperatures of the planets and the temperature profiles, and how close Venus and the Earth are in space to each other and far away from the sun. How unlikely it is that that small difference in distance between Venus and Earth versus the sun would actually cause climate change. This is the point emphasized by Jeffrey Bennett in his lovely book, A Global Warming Primer, which I recommend to you. We talk about the water cycle. We talk about the carbon cycle, how it takes 400,000 years to stabilize, and we can't do that with our rate of increasing CO2 in the atmosphere. Talk about the Keeling curve, evidence for connections between CO2 and temperature, and how strong a link it is, whatever the exact causality is. We talk about the IPCC reports, and how essentially all the models show significant warming in our future. And we talk about the specifics of that warming, where it's going to happen, when it's happening. We try and bring it home with all these plots and figures. And most of the students have seen these before in some way. I'm sure you're all doing some form of this in your public talks as well. And again, there is definitely a space for this. I try to make it local here by pointing out, oh, look, where's the darkest blue in this picture? It's right where we are in Massachusetts, the Northeast, where the largest changes are being experienced in the US. It's not just from CO2. Well, what is it from? It's all these different sectors in the economy, and different places around the world that are contributing in various ways, and facts and figures and numbers and plots and charts and all this dire, horrible stuff about the beetles taking over the forest because the winters are too cold to kill them anymore, and the polar bears are going to die, and your house is going to be flooded, and the island nations are going to disappear, and the climate of Massachusetts is going to be like the climate of Georgia by the end of the century, and the ice cap is melting, and it's worse than we thought. Here's something that's useful. Emphasize that scientists agree about this, and dispel the myth that there's a serious debate. And this is something that's been done by other people, and you can just copy their work. For example, this work showing that out of 928 papers about climate change, none of them were refuting the consensus position. I like to try to weave in some hopeful message about what you can do. Here is an example of what you can do. And I show a picture of Copenhagen that looks much more climate friendly than that picture of Shanghai, and try and put it into people's minds. What's an alternative to our current American lifestyle in any event that you might work towards? Here's the problem with all of that. The problem with all of that is students come in with crisis fatigue. They've already heard this stuff. They're overwhelmed with it. It's possible that some students are going to get something out of it because A, they haven't heard it before, or B, maybe I'll present it in some way that clicks with them in a new mode of their being or existence, or where they are at school or as people, and maybe it'll trigger some action. But by and large, I would say this has not really been a successful approach in my experience. And I feel as if to be inspired to act, the students need a different message. They need a message that is more hopeful, and they need to feel some possibility of agency. And I feel as if my job is to enable that, not just with the facts and figures that are my stock and trade, and probably most of ours on this call. We're very familiar with them. It's tempting to think if we just show more facts and figures, people will finally get it. It just doesn't seem to work that way. So here's a new approach. And here's a picture from my classroom from just a couple of months ago, showing students engaged in this approach. And you can see the pleasure in their faces, and you can see in their bodies, their body language, they are engaged. And you see two people holding bags of candy, and we'll get to that in a second. How does that weigh in here? We are using a tool developed by MIT and a branch of UMass called the United Nations Climate Summit, and also called C-Roads and N-Roads. These are all slightly different flavors of the same thing. It's built around a tool, and you see a screenshot of the tool here, an online tool that lets you provide some inputs and get a prediction for what the temperature increase will be. The inputs are pledges from different regional parts of the world about how they will reduce their own greenhouse gas emissions and take various mitigation steps. And it's done in real time. So here's the setup. Here's a screenshot from the website for Climate Interactive, and there's the URL. If you go there, you'll find lots and lots of resources. These are the resources I use. What I download from them, and I just keep on my disk, and I use it semester after semester now, a lesson plan to get you going the first time you do this, a slide deck, a PowerPoint slide deck. You can use it or modify it as you see fit. Some regional briefing summaries, where the regions are 6 regions of the world, and each summary gives the students a brief idea of what the economy and culture and climate perspective is for that region of the country. Table signs, because I'm going to put the students in groups physically in the classroom, and each of them will have a table sign for their region or their group, and this real-time climate model. So those are all the things you get from this website. Here are the 9 groups. Ahead of time, about a week before our big day, this is what we divide the class into. 6 regional groups: China, US, European Union, India, other developed countries, other developing countries, and then these 3 non-regional groups, a group of fossil fuel lobbyists. Those are the ones with the bags of candy. And so the candy represents money that they can use to influence and bribe other groups. Climate activists, and I give them a bunch of arts and crafts and paper and tape and pens and stuff so that they can make disruptive signs and go crazy as climate activists. And then journalists. And I give them the following instructions. The whole class is given these instructions. Find your team, download the team briefings. With your team, decide on a spokesperson. And if you're in one of the 6 regional groups, decide on some commitments. If you're in the China group, decide what year you will commit to reach a peak in your emissions and what year you will commit to reducing your emissions, and what rate in percent per year you will agree to reduce your greenhouse gas emissions. How much deforestation are you willing to prevent, assuming you're doing any now? How much will you commit to reforesting areas that are currently deforested? And finally, how much money are you willing to put into or take out, or how much money are you going to ask to take out of the global fund agreed to at the Paris meeting nearly a decade ago now? And then I ask all the students to think ahead, to write a brief summary reflection after the event. So that's it. The students have to do a little preparation. It's sort of a homework worth. Really, the preparation is mostly in reading their briefing. If they want to do more research, they can, but I don't require it. And then it's just getting together with our group briefly to decide, okay, we're going to stop our emissions in the year 2030 and start reducing them by 1% per year, 2 years after that, for example. Here's what the info looks like that they see. They'll see a briefing for their region, like the United States of America or China, in this case, or they'll see a briefing if their group is the climate activists, just to get the juices flowing. And then if they're one of the 6 regional groups, here's the commitment form that they have to fill out. Fine, do that ahead of time, and we all come together. On the day of, it's just a regular class. It's a 75-minute class. There are many different ways to do this. You could stretch this over a week. You could potentially do it in less than a 75-minute class. It's going to be pretty compressed. It's compressed enough as it is. I bring some props with me, a bunch of flowers. What do I do with the flowers? I arrange the chairs into the 9 groups, and I put out the placemats, the place cards, and the United States gets some flowers. The European Union gets some flowers. India gets some wilted flowers. China gets some wilted flowers. And the developing and developed countries, they don't get any flowers at all. This is kind of a crass and cruel way of reflecting the dominance of the United Nations by the developed world now, and how decisions are made, and how the Security Council is run, and how the major decisions are made. As I said, candy for the fossil fuel group, art supplies for the activists. I bring a blue bed sheet and spread it on the ground. I actually set up chairs for only 8 groups. Other developing countries, sorry, we don't have enough chairs for you. You have to sit on the ground here. The blue sheet actually represents the ocean, and that's going to flood over them later, probably. And I bring a jacket and tie, and I stash it on the side. All right, so I set up the chairs. I start the PowerPoint slideshow that I inherited from Climate Interactive, but with my own flavor to it. I pretend I'm a high up muckety muck in the United Nations. You know, this is a role play exercise, and I think it works best when people really inhabit the roles. And so I help to model that by taking on a role myself, first as an official in the United Nations, and then I introduce the Secretary General. So I go out of the room, I put my tie and jacket on, I come back in as the Secretary General, and I call the meeting to order. And I use formal language, even though I don't know the actual formal language of the UN, I make it up. I welcome the delegates to the UN, and I continue through the PowerPoint slideshow that is a brief primer about climate change and the importance of working together. And then one by one, that's just 5 minutes of PowerPoint. And then I invite each of the 6 groups to stand up. Their spokesperson stands up, gives a sort of 1 paragraph, couple of minute intro statement about what China is willing to do, what the United States is willing to do. And they announce their commitment, and I enter those numbers directly into the climate model in real time. And as we do that, we can watch the predicted temperature drop from a 4.2 degree increase by 2100 down tick by tick by tick by tick. And we're aiming for the Paris goal of 1.5 degrees, or at worst 2 degrees. After we've done the round of the whole group, all 6 of them, I guarantee you, if they're doing a reasonable job, unless they're making unreasonably large commitments that would never actually fly in reality. I mean, we all know how much trouble it is to get any country to commit to doing the right thing. Unless they're wildly optimistic and ridiculous, there's no way that on the first try, the group is going to reach 1.5 degrees or even 2 degrees. So we see that happen, and then we go back to the negotiating table. And the group sort of sits there in stunned silence, and I say, okay, well, now you have to negotiate with each other. And the class turns into frenzied, nearly chaotic hubbub of just cacophonous, frantic negotiation and bribing and interruption and back and forth. And United States goes to India and says, well, look, we've got money. We'll give you more money. We'll promise to put more money in the pot if you will promise to do more afforestation. And the developing countries come to the European Union and say, you created this problem in the first place. It's your fault. I mean, it's great stuff. And it's actually hard to get people to be quiet. And I don't want to, I let it go for 10 minutes, 15 minutes, and it could go on probably for the rest of the class. Meanwhile, the climate activists have taped themselves to the board and as a protest, and they're making paper airplanes and they're sending them out around the room. And the fossil fuel lobbyists are going around with their chocolate and they're bribing countries not to cut back on fossil fuels, but to convince them that it would be in their best interest and their economic interest to keep burning fossil fuels, but to try and do other things like, pay for your sins and do more afforestation and less deforestation, et cetera. It actually works. People change their minds based on this influence. The journalists go around and eavesdrop and occasionally interrupt and make announcements in late breaking news about the climate negotiations. This is a really highly interactive process and day, and it's very, very lively. There is just not a dull moment in here. Oh, I forgot to say, when we first do the first round and we only get to 3 degrees instead of 2 degrees, sorry, but the ocean has risen so high that you developing nations are now drowned. And I take the blue sheet and I drape it over those students sitting on the floor, and they're drowned. And now they're forced to, their nations no longer exist, and those individuals go join other nations and other groups for the remainder of the negotiation. Eventually, we force it to come to 2 degrees. We just make it happen. And we'll see in a second. We're going to do this in ourselves. Here's just a quick sampling from the reflections. I really enjoyed my time protesting. It got a little more depressing towards the end, but I think the activity prompts a more personal investment than just doom and gloom. Seeing the other group's pledges was eye-opening. I learned a lot about the crisis, didn't realize how drastic of measures we need to take. This is a very common theme. Everybody needs to work together. You cannot get to 2 degrees just with the United States alone, or just with developing countries alone. And this last one here, I think, reflects that it doesn't matter who the biggest offender is, as much as whoever has the most to contribute towards fixing it. The Earth is like a ship. If it crashes, everyone will drown. And this message really comes across, and it shows in the reflections again and again. So shall we try it? Okay, let's try it. Now, to do this, I'm going to need to stop the share and start another share, because it's going to go to my Google, my Chrome, which I'll now share with you. Here it is. And let's see, how many people are online at the moment? Olivia?
We have 16, including all the speakers. So
okay, then how about this? Everybody whose birthday is in January or February, you're in the United States. You represent the United States. If your birthday is in March or April, you represent the European Union. If it's in May or June, you're in other developed nations. If it's in July, August, you're in China. If it's in September, October, you're in India. And if it's in November, December, you're in other developed nations. Would someone from the United States, are the United States delegates ready to make a pledge? By what year, before 2100, do you pledge you will stop increasing your emissions? Anybody from the United Nations, just pipe in. I mean, from the United States.
Feel free to write in the chat as well.
Or
if
write it in the
anyone
chat.
is January, February birthdays.
2040.
That means I need to get the chat going. Hang on just a second. I've lost my controls. Okay, now I have the chat again.
I'll read stuff to you as well. I think we had a 2040.
All right, very good. 2040. So you just type that in and you hit return, and you can see changes here. All right. When will you, United States delegate, when does your group pledge to start reducing, not just plateau, but start reducing emissions? Has to be after 2040, 2060. Okay. And you can see it didn't really change much. How much will you agree to reduce by every year? What percent starting in 2060? 8%. Okay, probably unrealistic, but we'll go with it for now. Oh, look what just happened. Here, I'm going to change that back to 0 so that you can see the red line here. The red line represents the United States contribution. And we just brought that down to 0 by 2100 with that big drop. And how much deforestation will we prevent per year? 10%. And we also have to commit funds to taking currently forestable lands that are not forested and reforesting them. What percent? 5%. We'll add that in. Okay, now you can see how it works. We're not going to go through the whole thing. It'll just take too long, but you get the idea. At this point, I hope each of you feels a certain investment in it. You're part of a group, and it's hiring, it's tapping into all of our social desires to belong to a clan, maybe to do the right thing, but you're going to be talking with group members. You have some vested interest in your group. You also have a vested interest in trying to make the numbers go the right way. So let's just put some other numbers in here just for kicks. Let's make this 2025 and 2027 and 2%. Oh, you just saw the green line go dropping down quickly, and 10% and 10%. And you can see we're still at 3.4%. All right, you all get the picture. It takes a lot of work. And here we can see where this big line is, other developing countries. Let's just jump to other developing countries. So you November and December babies, can you pledge a, oh, can we ask a question or wait for the end? Why don't you ask it now? Marina.
Hi, can you hear me?
Yes, I can.
Yeah, no, I just wanted to ask, so when you do that in the class, so here we were just saying numbers like that, I guess, but what is the goal of each country? Because they have their own economic interest and so on, but what are those? Because otherwise we can just say unrealistic stuff.
Of course,
so how do you
yes.
define their
Yes.
interests that is
Yes,
not
thanks.
necessarily the
Thanks.
good of the people?
It rests partly on their willingness to inhabit the role, and largely on the information that I give them beforehand, which comes from Climate Interactive. It's that two-sided summary sheet, one for each region. If you're interested, we can later look in more detail at the info briefing sheet for the European Union, for example, where it says, well, here's the history of climate, of greenhouse gas emissions in the European Union. Here's what the economy is like now. Here's what people are mostly saying in the European Union about climate. Here's the way people feel about it. Here are the attempts that have been made recently. Here's where the political will is or isn't. And here's what the economy depends on. And what it's sensitive to. So it tries to fill those in a very basic way. Obviously, it's only two sides of one sheet of paper. You can't go into tremendous detail, but still, they're coming to it from their one single perspective. They might not know any of that about another part of the world. So it fills in that rough sketch for them of how they could give reasonable numbers, keeping in mind that they are representing a nation or a national bloc, and trying to represent the economic interests of that bloc balanced against the global desire to limit climate change. That's the beauty of this simulation, that it lets people inhabit that role of representing a particular nation or group of nations, while at the same time working towards
I
global
see.
climate
Well,
goals.
thanks.
Sure. Yeah, thanks for the question. Let's just see if we can get developing nations to make a big difference. And instead of peaking in 2100, let's make it peak in 2024 next year. Wow, look at that difference. That was a huge difference. And we'll start reducing in 2025 by an unreasonably large 3% per year. And you can see that blue line drop and drop and drop. And deforestation is a big issue. So let's prevent it by 10 and promote by 10. And okay, we got to 2.9 degrees Celsius. So we're doing much better than we were, but we still have to go back to the bargaining table. So again, you cannot do it alone. Everybody has to be involved, and it's a complex interaction. I have a little more to say, but I wanted to pause and see if there are other questions about this right now. We will have more time for Q&A, but if there are any particular questions about this activity right now for clarification. All right, well then I'll go on and just—
Sorry, I have a question again.
Oh, please, yeah, go ahead, Marina.
Sorry, I didn't found the, anyway, raise hand. Yeah, so it's something you mentioned a bit before, is that because of the setup you're putting to highlight some inequities with the flowers and so on, and also of the goal, because we can see that you're not even aiming for 1.5 but already 2 degrees, and it's already very complicated. How do you deal with the despair, let's say, at the end, because it's also very heavy emotionally, in particular for I don't know, but I don't know within your class, but depending also on your ethnic background and so on, it can be even more emotionally heavy to have this, to see this inequities and so on. So
yes,
how do you take a time for that, or are the students left with this feeling? How do they deal with it in the classroom?
It's interesting, Marina. In my experience, the students are so engaged in the process that it's actually, I feel as if that's the magic of this activity, that it actually promotes engagement, and I think engagement leads to hope, and it fights against despair. I almost never see in the reflections, I showed you some of the quotes, and it's a required part of this process. Everybody gives me some reflection afterwards, and they do not write about despair. They write about how impressed they are, how grave it is. It impresses them how much everybody needs to work together, but they all say it was fun. They say it was interesting. They say it was engaging. My feeling is it's engagement that leads to hope. And that's what I'm trying to promote. And I've heard this from other people, that you might know about the Sunrise Movement here in the United States, which is a youth climate activist movement. It's one of their mantras as well, that not doom and gloom, that you have to engage people, and the engagement leads to the hope. So
okay, well, that's interesting.
That's been my experience so far. Okay, other questions about this specifically before I just wrap up with a couple of other slides? All right, here is a very different approach. It's also not very much, anyway, traditional lecture. This is in a class that we offer at Smith called Astronomy and Public Policy, that has 3 topic areas, and one of them is climate change. 3 topic areas that touch on astronomy and public policy. And it's climate. In the climate section, students do these 3 things. And Olivia can talk about this more if you're so inclined, because you've been in this class yourself. For starters, we actually do a little bit of climate modeling ourselves. We use this simple model from Monash University, where you can put you can check all these different boxes in different experiments and see what the result is in a very simple-minded climate model. Here, all these important parts of the Earth have been turned off, so you're basically constructing the moon. And this shows you the climate of the moon that has no latitudinal, no longitudinal or continental effects, because that's all mediated by the atmosphere, which you've turned off. So students can get a hands-on taste for how climate modeling works. And we actually bring some local flavor into it as well. What does it look like in the United States in the year 2100? How about in the eastern part of the United States, et cetera? Okay, so they do that. That's a homework. It's fairly traditional. Two non-traditional parts. They also design an outreach project, and they carry that project out on campus or in the community at large. And it could be about one of the other topics, but if it's about climate change, they might go set up a table at the campus center and grab people coming out of lunch and say, where are you going with that recyclable or whatever. I mean, it's up to the students to design their own project and then actually carry it out. And they get assessed not on the success of the project, but on the planning for it, or mostly on the planning for it and the thought that goes into it. And then finally, students write and present a group TEDx style talk that may be about climate, if that's the topic they choose. And these are, again, ways to bring the students' own creativity and engagement into the process that is not just sitting listening to a lecture. Threaded, this is my last slide, I believe, threaded throughout the entire process is a philosophy about science communication that we have inherited from the Alan Alda Center for Communicating Science. This is a terrific resource. This institution, it's now a for-profit standalone institution, used to be, it's a spinoff from Stony Brook University in Long Island, New York State, devoted to teaching scientists how to be better communicators about science, and to the public, to the media, to other scientists, to their friends and family, to their classes. They specifically include a lot of climate training. And I've gone through a bunch of their training. I've collaborated with them. I've had a lot of experience with them. I brought them to Smith and helped them train other Smith professors. Here are these four bullet points are some of their main points. Distill your message, boil it down until it's simple and pure in just a couple of sentences. And if you can't say it in 3 sentences, then it's too complicated. Shed the jargon, empathize with your audience. They borrow a lot of techniques from theater. We do a lot of exercises where instead of meeting in class and sitting in chairs, the students, the whole class meets in a big ballroom, and we take our shoes off and run around in our stocking feet and play theater games and do improv and tell stories and act things out. And the whole goal of this is to train scientists to be better at understanding the audience, at putting themselves in the audience's shoes, in imagining what the audience is thinking and feeling right now. Are they ready to hear this message? If not, what message are they ready to hear? What do they already care about? What would make a difference to them? What are their values that they have that I also have that we share, that we can talk about as a starting point? Empathize with your audience and use stories. Don't just give facts and figures. Start with a personal story. Think about the narrative arc of your presentation, whether it's 30 seconds or an hour. So we practice this stuff a lot. And this photograph here shows one of the students in a recent class in downtown Northampton, meeting with a total stranger and interviewing that stranger about science questions. We have the students decide on science questions early, like can you name all the planets? Or why does salt help melt ice? They come up with their own questions. And then they interview the public just to try and get a sense of how much the public knows or doesn't know, so that they know their audience better. This is just part of the process of getting to empathize with their audience. So I think this is a successful model for teaching climate change or any thorny subject like that. And I'm looking forward to spring a year from now when I'll be teaching this class again. And with that, I will say thank you so much for your attention and your questions past and to come. And I'll turn it over to Olivia and Ryan.
Thank you so much, James. It's awesome. And yeah, I propose let's hand the floor to Ryan and Dan, and then we can open up for questions at the end.
Sounds great. I guess the question is, so Dan is currently showing what will be my slides. And so if we can pin him, that's great. So again, my name is Ryan Wyatt. I'm for the California Academy of Sciences. The next slide, we have the requisite title slide. My title, as I mentioned before, is Senior Director of Morrison Planetarium and Science Visualization. And as we talked about what I could talk about today, the idea that I'd kind of touch on both of those things came out. So I'm going to try to talk a little bit about planetariums, a little bit about science visualization and how visualization can be leveraged to talk about these topics. And then, because I can't resist, I'm going to step up on a soapbox briefly to kind of talk about some visualization do's and don'ts. And then sort of wrap up with a bit of the story concept that James mentioned so eloquently, and more of a science story than a personal story, because although planetariums are wonderful immersive environments, they're not always great for personalized stories. And so trying to just talk about how we kind of weave some of these narratives together in the planetarium. So I think we can switch over to our view of the interior of Morrison Planetarium. Morrison Planetarium is located at the California Academy of Sciences, which Dan is going to switch over to show us in the context of our map of Earth. We'll fly away from the Academy's location in Golden Gate Park. And I just wanted to start by emphasizing that there are planetariums all around the country and all around the world. This is a KML showing locations of planetariums around the world. And it's a unique opportunity that astronomy has to have essentially branch offices around the globe. And one of the things that I think is unique in astronomy, it's not like there are chemicalariums or geolariums or something. Astronomy has this sort of amazing resource in terms of local knowledgeable experts. And if you can build a relationship with your local planetarium, it's a great opportunity to bring your science to their audiences. And I can almost guarantee you, although planetarians, people who work in planetariums are often a little busy and distracted, they're usually very eager to engage with these science topics. Let's actually switch back to the slide deck for a moment. And I started out here in the interior of Morrison Planetarium. If we go to the next slide, you saw this as an this is I wanted to mention briefly the history of planetariums. This is the original Morrison Planetarium projector, which is a visualization instrument of its own. It's just that it visualized only one data set. And this is the sort of the traditional planetarium technology. If we go to the next image, that data set was cutting edge for its time. The planetarium was built in 1952. It had accurate star positions for several thousand stars. If we go to the next image, if you print out those locations, you have this wonderful image from, again, the late 40s, early 50s. And that's what planetariums did for many decades. The planetarium technology turns 100 this year, but the majority of that history was really focused on the night sky. And what happened over the last couple of decades is that we've transitioned to a digital environment. And so this is the new basement of Morrison Planetarium, where we have plenty of machines to drive essentially the largest computer monitor in the California Academy of Sciences, and to drive it using 3D simulations that we can fly through in real time, as well as sort of beautifully produced pre-rendered movies that we create on site. But to put this in a different context, starting with the history, but now going to kind of where we are, it's worth noting that the Morrison Planetarium, and this is a rare view because normally there are actually lots of people in the planetarium. We see 290 people. It's a little different from a traditional old school planetarium because it's tilted 30 degrees, but it's a very immersive experience. But this is actually situated inside California Academy of Sciences. And if we looked outside the dome, we would see the living roof. And so in the next image, you can see our Renzo Piano designed building. We're an institution devoted to the life sciences. So all of our research and much of our education is focused on biology, and our mission is actually to regenerate the natural world through science, learning, and collaboration. So we actually have a strong environmental perspective that we take on all of these topics. If we zoom out to the next image, this is almost similar to view that we had in our real-time software that Dan showed, but our living roof and our LEED Platinum building are part of this whole narrative. And the reason I bring this up is because this is the context in which we have integrated astronomy. So I think there's something interesting about flipping that narrative and thinking about how you can turn that around and bring astronomy to connect with these other topics. Because although underneath that one dome on the left-hand side is the planetarium, underneath the on the right-hand side, we have our Amazon, our rainforest, which is actually representative of multiple rainforests around the globe. If you go underground in the building to the next image, you'll see our aquarium with live presentations, as well as in the next slide, just places where you can sit and sort of contemplate. This is actually seen from the other side of the tank. But this is representative of the context in which we're talking about astronomy. And so connecting this story of life in the universe is something that we do all the time. This link here is to learn a little bit more about our team. We produce planetarium shows. We're working on our 9th planetarium show now. And this is an image of the team working on one of our shows. It's a show that touched on Enceladus. So that's the scene that we're seeing right there. But the overall narrative was really about how understanding life and Earth, so how life co-evolved with our planet, informs our search for life elsewhere. And then this sets up an opportunity to weave in stories about climate and our relationship to the natural world. So that's kind of the planetarium. Part of the show that I wanted to, story that I wanted to queue up. But switching gears to talk a little bit about visualization, I just wanted to at least mention a couple resources for, I mean, I think James presented some great graphs and things like that, but in terms of video media, if we go to, for example, this great site, which is from the Goddard Science Visualization Studio, I'll go ahead and put the link in the chat. The Visualization Studio has a whole climate essentials collection of videos. One of the more famous ones that you might have seen is the climate spiral. This is something that got a lot of attention back in about a year or two ago on social media. It shows the changing global temperature in a kind of graphically interesting way that really seemed to engage people in it. It's one of those visuals that I think is a kind of an interesting question as we talk about how to bring these topics to people's attention. Being able to even represent data in a compelling way can at least bring this sort of top of mind and help people think about, talk about, share these ideas, because one of the challenges we face with climate change is that we need people to talk about these topics more. And so even having these visualizations that can help kind of trigger conversation, I think is very, very valuable. And I'll just note that, like, another example, if you go for something that's perhaps not as radical as the amazing sort of United Nations approach that James is taking, is this particular video is just kind of an interesting example of showing visuals that are accompanied by sort of graphic representations of data, map representations of data. And I think in terms of being able to make use of this and leverage in a more traditional academic setting, it at least allows for, you know, scrubbing back and forth in the video and being able to connect some of these disparate representations of data that people see. Because one of the challenges that we have as we're inundated by all of these representations of typically grim data sets is that we want people to at least understand what they're looking at. And we're so overwhelmed by that. And that's something that I wanted to talk about as we go back to our slide deck, that I think is helpful for us to keep in mind how people are making sense of the images that we're presenting to them. So you may have seen this. This is an example of a list of words that have a specific meaning for scientists, but a different meaning for members, more sort of novice members of the public. So those who are not kind of exposed to the scientific vernacular. When you talk about, when you use a word like enhance for the public kind of general meaning of that means to improve, whereas what scientists often mean is something that is intensifying or increasing. So this is a great example. I put the link in the chat again to think about how we use language to describe these. And I think that's something that's well discussed, but I would also draw attention to the fact that we need to think about how we represent the visuals that we present to our audiences, because our visuals are also encoded in ways that are familiar or unfamiliar to our audiences. So if we go to the next image, I think I really want to just have maybe two main takeaways here for thinking about how you present visualization. I'm actually going to choose some examples from astronomy here as well. And those are very simple. Just explain what people are seeing. And then this is my soapbox, just avoid the rainbow color palette. If you're making your own visual, or if you're looking for what visual to use with audiences, please avoid the rainbow. So to elaborate on both of those, if we go to the next slide, this is sort of a very traditional representation of not so much an HR diagram, but a sort of conceptual representation of where we find different kinds of stars within the HR diagram. It's the kind of thing that is sort of overwhelmed with, and is it a visualization or not? We can discuss that, but it's sort of overwhelmed with annotation and things like that. But it is at very least very descriptive. And one nice thing about this is, since I'm going to cue up this idea of rainbows, the color here actually kind of sort of means something in terms of representing the color of the stars themselves. That's like something that you can connect to. Now, what's first of all somewhat deceptive about this is, of course, red giants are not vermilion. They're not that shade of red, and blue stars are not that deep kind of purplish blue. And so it's this interesting collision of an ordered spectrum. So for those who think in these terms, the spectrum has the kind of Roy G. Biv, or whatever the reverse of that is, the way it's depicted here. But color is not intrinsically ordered in our visual system. So we, as sort of expert observer or readers of this content, will see it as something that has an implicit order in it. But that's not the way more novice observers or readers of these visuals will see them. So if we go to the next image, this is actually a really old image, but I like it because, again, I'll come back to it because it shows why the rainbow color palette is deceptive. And unfortunately, since I can't really interact with folks here, normally when I put this in front of an audience, if I'm talking to, I've given a presentation around visualization to everything from sort of business people to science university students to high school students. For those who are kind of steeped in the science vernacular when it comes to image representation, if I ask what the color means, and notice that it's not really ever described anywhere in the annotation for this, people will immediately come up with number density. And this is, in fact, all the Hipparcos catalog of stars represented as an HR diagram. However, a novice viewer doesn't understand that color representation, so you end up creating something that is potentially confusing when you share images such as this. To give a couple other examples, moving away from the rainbow representation and into more graph representations, I'm going to present two images sequentially here, both from Webb. The first is this very familiar sort of eclipse transit representation. And what's nice about this is it actually uses the representation of the x-axis is time. And so you're seeing a change of brightness over time. And what's interesting is that most representations of sort of a line graph that people see represent change over time. So this is a familiar representation in vernacular, even without looking at the labeling of the axes. People sort of read it correctly ish because it's in a format that is made familiar by other representations that they've been exposed to. If we go to the next image of same result, but different representation of the spectrum, of course, spectra are sort of infamously difficult to communicate to students, but notice that in many ways, this looks exactly the same. Like there are no visual cues to suggest that they're seeing anything different. And if it's occurring in a paper or other publication, that's not such a big deal. But when you're talking to a range of audiences who will have less familiarity with the content, it's helpful to provide more cues. So not that this is a terrible representation, but this goes to my first point. If you do show something like this in a class, take the time to describe what the axes mean. Take the time to kind of explain what people are seeing and help them interpret it. So that's kind of my first point. I will end that with one example from our own planetarium show. The next image is our representation of spectra, actually terrestrial spectra, calculated spectra basically representing on the top forests, in the middle sort of desert regions, and in the lower part oceans. And we introduce the visible spectrum first. This is part of an animation, and then talk about the infrared portion of the spectrum as part of the spectrum that is not visible to human eyes, but actually we don't even label the axis. So we introduce this idea of breaking up light into constituent colors and then expanding it, and in testing this with audiences, we found that scaffolding it in that way made good sense to people. So then to move on to my second point, as I noted, and this is another great reference, and let me make sure that I put this in the chat. But if we go to our next, oh, no, I don't have it here, sorry. It's down at the bottom of the screen. Sorry, if we can go to the previous one. This is Noah Alinsky's chart of visual encodings. I'm just going to drop this here, and knowing that this will be recorded or whatever, and people can go back and make reference to it, or you can do a screenshot and grab the URL. This is a great sort of chart that talks about how different visual encodings are interpreted. And basically, our visual systems evolved to kind of deal with certain kinds of phenomena. So some visual representations are kind of inherent and build on that evolved kind of processing that our brain does with visuals, and then other things are not. And a good example the sense of, like, if you look at color here, explicitly says it's not good for ordered data sets, even though that's often what we use them for in science, because of that familiarity of the sort of Roy-G-Biv spectrum. So to dive into that for a moment, if we go to the next slide, which got a little bit of a spoiler from already, this is actually indebted to Robert Hurt from the Spitzer Science Center, who talks about ending the painbow. Painbow is a reference in the next image to the XKCD comic that talked about basically the kind of horrible color palettes that are often used in representing science data to the public. And he talks about the Painbow Award being offered. If you look at the next image, this is a site that I didn't even know existed until recently. There's XKCD Explained. So if there's anything you don't understand about XKCD, you can just go to XKCD Explained and learn more about whatever topic Randall Munroe is lampooning. But in this case, there's actually, you can't see it in the article, but there's actually a great description of the challenges with the rainbow color palette. To give a couple examples of why this is so difficult, if you look at the next image, this is the familiar WMAP CMB image. And if you just kind of look at this from a distance, the parts of the image that pop out to you are those bright kind of yellow regions. And yet those are not, in a sense, they're a distraction from the overall message of the image, because they are not as dense, not as hot as the red regions, and not as dense as the dark blue regions, but those are the most prominent artifacts really in the image. Go to the next image. The Planck group corrected this by basically using a diverging palette. Still not my preferred version, but at least the green here, again, the brightest color that really pops out at you is the sort of average value of the CMB, with the variations in temperature and density moving to the red or blue end of that spectrum. But if we go to the next image, this is actually the way we show this in Morrison Planetarium. We use a sequential palette, basically the darkest representing the coolest regions of the CMB, the brightest, the hottest, and that in many ways is easier to explain to our audiences. So part of this is that the rainbow palette really ends up creating artifacts that are deceptive for audiences. If we go to the next image, this has been well discussed in climate literature. And if you notice, many of NOAA hasn't been great about it. NASA's been better, in part because they've been called out on it, about finding color maps that work better for audiences. But if we go to the next image, one of the most important factors is that fundamentally rainbow color maps obscure detail. They introduce artifacts that pop out in a way that is maybe counter to the point you're trying to make. And then in the next image, there are other options, next image, but a lot of these suffer from being readable to colorblind people. So I spent enough time on that soapbox. I just wanted to kind of leave you with the 2 points. And now we can switch over to the open space software. Leave you with 2 points. One is that when you represent visualizations to your audiences, please just describe what they're seeing so that you can scaffold that for them. And then when it comes to choosing images, just avoid anything with that sort of traditional rainbow palette. Please, 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 and your audiences will appreciate it. So to kind of wrap up, I wanted to sort of present using our planetarium software, OpenSpace, which is actually open source software, a bit of a way that we've kind of talked about some of the topics that really are germane to helping people understand the foundations of what it means to live on a planet with a rapidly changing climate. We're starting at Mars here because, again, we kind of like to give that astronomical perspective. This is modern Mars, but we can artificially turn back the clock 4 billion years and talk about how, based on our observational evidence of in situ measurements on Mars, Mars once had, if not a large ocean, at least significant amounts of water on its surface. And so 4 billion years ago was a much more appealing place for life. I have to admit that the visual is not quite as impressive, at least on my screen, as it is in the planetarium dome. But one of the problems that people really have is the idea that Earth has changed over time. So if we can actually leave Mars behind to go ahead and visit Earth, we'll come up on Earth also in the past, not quite as far in the past, but looking at it about 280 million years ago can give a sense of how Earth has looked different over time, and that has actually influenced what the planet was like. Earth and life have evolved together, and actually, what's kind of interesting, if we could go a little farther back in time, which we can't because we don't happen to have the images here. Earth only turns green about 100 million years before this, a little less, maybe 70 million years. The first forest didn't appear on land until then, and now with the formation of Pangaea, because of plate tectonics, you have this continent that spans sort of an entire hemisphere of the planet, and the interior of that continent is extremely dry. If we go to the next image, into the Triassic, we start to see the continents pull apart. We move forward to the Jurassic. We see that even more becoming more familiar as we move forward in time, as the continents kind of shift into their current positions. The interior of the continents turns greener because the land masses are not as the circulation model is not the same. The water is able to kind of reach the interior of continents. And actually, if you kind of look over to where on the right-hand side of Earth there, where the Sahara eventually will end up. It's an extremely wet environment and actually home to lots of scary carnivorous creatures at the time, everything from pterosaurs to ancestors of the crocodiles. So one of the ways that we talk about this in the planetarium at the Academy is this changing planet over time, underscoring this idea that Earth hasn't always looked the same and it won't look the same in the future. So all of the effects that we've talked about so far are really related to the shifting continents, the life on Earth that has driven interacting with the shifting continents to drive different biomes on our planet. But of course, now with the influence of humans, we are seeing the effects of our presence on Earth. And often when we talk about this, we try to bring this back in time, that it's not just like the Industrial Revolution, but actually we can step through periods of time starting in the 18th century, so around 1700, that show basically the wild areas of the planet are this light kind of pale blue. I apologize, I'm colorblind, and I should have reviewed this color scale before I dove into this. But areas are color coded by their use as pasture, as cropland, and you can sort of see the human influence in the regions that are green, orange, red. So in 1700, you can see Europe has clearly already become sort of terraformed by human presence, whereas other portions of the globe remain sort of unaffected. As we move over to the North America and the United States, you can see that the human influence is measured by land use change from into cropland and pasture land has begun in the sort of early 1700s. If we move to 1800 and forward, we can see that transformation continue on into, I think, 1900, or are we now at 2000? Since I'm not, okay, so this is 1900, and then moving forward to 2000, you get this sense of the rapid urbanization of the US and the land use change that accompanied the movement of colonization over into the Western Hemisphere. And these are all effects that have changed climate at smaller scales. But this does offer a glimpse into how humanity has changed the planet over a long baseline. And now moving forward into the 21st century, how we can look at these effects as well. One of the things that we often talk about, because we have a rainforest in our building, is the effect of deforestation in various rainforests. I think we can quickly show a data set here showing deforestation in the Amazon, which of course is sort of where people think of deforestation occurring. And we can look at this going from, if you want to just move through these, Dan, that would be great, from 2000 in 3-year increments, from 2000, 2003, 2006, when we sort of the maximum rate of deforestation was occurring, and then on into 2012, with the lag time between these snapshots, it's a little challenging to see, but we can talk about the way our land use changes affected deforestation in the Amazon. Unfortunately, what was a success story in terms of the decreasing rate of deforestation even 10 years ago is not such a happy story now, with changes that are occurring recently. But maybe we could pull back and show the deforestation map for 2015, I think, and that shows where the deforestation has occurred most rapidly, and the brighter areas are regions that are being deforested quickly. So that series of snapshots would then translate into these bright areas representing places where deforestation has been occurring, as I said, fastest, most rapidly. And of course, then this is linked to the role that the Amazon plays in its own climate and in the global climate, because at some point, the concern, of course, is that the Amazon will reach a tipping point where it no longer can effectively produce its own rain, which it does now. Maybe we'll skip Madagascar and just go to California, Dan. But we then try to bring this story to a more local and contemporary perspective when we talk about that same deforestation map in California, because again, we're the California Academy of Sciences, and we can talk about how, and of course, with the sort of increasing importance, or at least top of mindness of forest fires in California, Californians are more and more concerned about their forests. Again, these bright regions show areas that have been deforested most rapidly and recently. And the challenge is that it's not possible to simply reassert an old growth forest. We are not giving our forests time to regenerate. So to that kind of last box in the interactive that James showed, one of the challenges we have is figuring out how to change the story at a local, regional level. And that is often where we focus a lot of our narrative in the planetarium, to sort of bring it home to people. And in a sense, I told a story in reverse from what we often do, although I told it forward in time from hundreds of millions of years ago to contemporary time, and from a global scale down to our regional California scale. Often we flip that to start at a regional scale, help people think about topics that are relevant to them, and then expand that perspective to a regional and global scale. So I want to thank Dan for being our pilot. I think given the time, maybe I'll wrap things up there. This is fun to do in a Zoom, but it's much more impressive and much more sort of emotionally engaging in the immersive space of a planetarium dome. So I'm sorry I couldn't take you all into Morrison Planetarium to share that last few minutes of our tour from Mars to Earth. But I want to thank you for taking the time, and I'm happy to answer any questions.
Thanks, Ryan and Dan. If anybody has any questions, can go ahead and ask. Otherwise, I just wanted to let everyone know this session was recorded, and we are planning to post it on our Earth Week 2023 webpage. So you'll be able to look back at that. And also all of the resources that were mentioned today will go up in a summary post. So all of the links in the chat, everything will be accessible to look at later. And if nobody, oh, we do have a question in the chat. Ryan, you're muted.
So the question about the hardware requirements, Dan might actually be able to answer in greater detail. It is very graphics card dependent, and for better or for worse, it works best on a Windows machine. It will, so the OpenSpace software specifically, it will run on Mac, but it's basically you have to kind of turn off a few of the bells and whistles to make it run smoothly. One of the things I didn't mention that I just wanted to kind of reference as a resource is Eyes on Earth, and I could put the link to that in the chat. But Eyes on Earth is a great resource that doesn't what's nice about open space is it puts all of this into three-dimensional context with the solar system and other objects in there in the universe, but it doesn't allow for like desktop use in that very easily. So if you go to NASA's Eyes on Earth, they have a great vital signs tab that's right on their front page. And that can allow you or students to explore some of the Earth-oriented data, although not, it's not all integrated into one package like it is with open space.
And the only thing I would add to that is it is not compatible with newer Mac M1 processor chips because it's a totally different architecture. So effectively, Macintosh support is eroding away for the software, but it does run on PC. There are still Linux builds for it. And yeah, it's totally runnable on consumer level hardware. In fact, in many applications, because it although a lot of the stuff is graphics card based, the map layers are very heavy on the CPU. So it runs very well sort of with a high-end like gaming spec CPU GPU combo. So anyone who wants to know about that, you could definitely reach out to me afterwards. We assembled our system all out of consumer off-the-shelf hardware to do this, and I'm happy to share everything that we put together for that. And my email is dtell@Cal Academy, so it's probably easy to figure out. So always happy to share what we did to build out our cluster.
And similarly, with the planetarium project that you mentioned in the chat, we're always happy to talk about how to leverage planetarium technology. So feel free to reach out to Dan or to me, and I'm just R. Wyatt at calacademy.org.
Yeah, James.
I just want to say, Ryan and Dan, thank you for sharing this with us. And I want to give a plug for more and continued and enhanced collaboration and communication between astronomers and planetarians. And I really firmly believe, I've come to understand, I would say too late, how powerful a combo we can be together, how powerful planetariums are by themselves, how many more people you reach than we astronomers reach every year. I mean, we talk about hundreds of thousands, you talk about millions and millions of people that you reach every year. And it's such a great opportunity to get these important messages across. And you are so immersed in the latest in narrative and storytelling and graphics and science communication. It really is powerful stuff. And I'm so happy to be able to talk about it together with you. And I hope that our communities can really be productive together in the future.
Yes, thanks for that. And I think that, again, branch offices in every town and city around the world, your local planetarium will almost certainly be eager to talk to you and to learn about your work and to talk about how to share these stories. So.
Awesome. Yeah, just to add to that, I'm very consistently amazed how many resources there are within science communication sphere, but specifically climate change communication, how much visualization tools and like the tools that James showed in the classroom, there is a lot, and it's really great to have these conversations so we can just share the wealth. If anybody has any other questions or comments, or we can wrap up here.
Did you want to mention the rest of the events for the week, Olivia?
Sure, I can do that. Yes, I really appreciate everyone coming. I know we have a somewhat international audience here today, which is awesome. And I hope everyone managed with the Zoom link registration. So tomorrow we have our discussion on the 6 Americas and implementing that in communication strategy. And then we're finishing up Earth Week with our Friday panel session. And the times and registrations for those will be on our webpage that I'm sure you've all found. And yeah, updates will be there. The post summary for this session will be there. as well as all the other sessions. So if you're not able to make any of them live, you can go watch them or read summary. Yeah, thank you all for coming.
Thanks for organizing, Olivia.
Thanks very much.
Thanks everybody for coming.
Yes.
Thank you very much.
Goodbye all.
Bye.